Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to continue to look at percents and their proportions. All right, you know that there's a few materials in order to be successful that you are going to need. First, you're going to need your Envision textbook. That's the one with our little robot buddy on the front. Second, you're going to need your math notebook so that you can take those beautiful notes. Third, you're going to need a pencil to take those beautiful notes. And fourth, last but never ever least, you're going to need that positive math attitude. All right, my friends. So this video goes really well with lesson 3-3, which again is using percents and using some equations and proportions in order to solve some percent problems. The key concepts page for lesson 3-3 can be found in your textbook on page 158. All right, my friends, let's walk through each of these three little expressions that we got going on. So the first is that proportion that we have been using to find percents, right? You have your part as your numerator, your whole as your denominator, and that's equivalent or equal to a percent proportion. So the percentage over 100. Just a reminder, the denominator for your percent proportion, always 100 because percents are based off of 100. So we've used this before, we're going to use it again. But here are some cool new tools I want to also give you, all right? Another way you can find it is if you take the part and you divide it by the whole, then that will equal your percentage. Or if you're looking for the part, you can take your percentage and multiply it by the whole, and that will give you the part as well. So let's kind of play around with these, my friends. Let's put these into practice. The first problem that we are going to look at together is on page 158, and it's number 4. All right, my friends, lots of stuff going on. Let's take a peek at what's going on. So over here, those are 3 different equations, things that we're probably going to use to be able to solve different problems, right? Please make sure this is in your notebook, all right? That's why it's like circle. That's why it's like over here, because like important stuff. Make sure that's in your notebook. Okay. So this problem is talking about insurance. Whoop, whoop, super fun stuff. And what it's talking about is commission. So commission is something, if you have a job and you work on commission, that means that whenever you make a sale, you get a certain percentage of that sale. That's money that you get, all right? If you work in like retail stores, stuff like that, commission, it's a thing, right? Okay, so what we're saying is that for each brand new policy that these insurance agents make, they get 12% of that amount that they get to put into their pocket, right? That's commission. That's how much they get paid for that, okay? So the question is, my friends, if this policy is $1,000, what's the commission, right? So let's think. Let's use this percent proportion first, and let's kind of fill in the information that we have. So all I did was I took this proportion and I plugged in the stuff that I had, right? So the whole is $1,000 because that's how much that entire insurance policy cost, correct? 12 is my percentage because, well, first of all, that's the only percent that it gives me, but also because that's the percent of commission, people. And we know that 100 is always, always, always the denominator for this proportion because percents are out of 100. What's my missing piece? What am I trying to figure out? The part, right? What is 12% of 1,000? So, like we talked about in previous videos and during our Google Meets, the way that we can solve this is to cross multiply and then divide. So think of an X, the 2 numbers that are diagonal, those are buddies. You're going to multiply them together. The one that's the odd man out, so 100, that's what you're going to divide by. It should look like this. So I rewrote our proportion into an actual expression, right? So we have 1,000 times 12. Notice that's in parentheses because we're doing that piece first, and then we'll divide it by 100. Let's continue. Once I solve my parentheses, I get that 1,000 times 12 is 12,000. That piece needs to be divided by 100, correct? Remember, when we're dividing by powers of 10, like, I don't know, 100, we just take that decimal and whoop, scooched over 2 spots. So your final answer would be $120. So what does that mean in the context of this problem? So glad you asked. What that means is that if you are an insurance agent and you sell a $1,000 policy, you'll get 12% of that, which is actually $120. That's your commission that you get to keep in your pocket. So we've used the proportion. We've like cross multiplied and divide before, but maybe you're like, Mrs. Schlecht, I totally don't believe you that you can use those other 2 and be able to get the same answers. Well, you can. So let's check. All right, so the first one that I'm going to use to check is this middle one right here, where we take the part, we divide it by the whole, and that should give us our percentage. So the way that should work is our part was 120. We already figured that out, but let's test it, right? Our whole was 1,000, and that should give me 12%. Let's see what we get. So you probably noticed that when you actually do this calculation, you end up with 12 hundredths. Now I know that's not the same as 12, right? But it actually kind of is, my friends, because how do we write 12% as a decimal? Bam, 12 hundredths, just like that. So yes, it gives you this answer as a decimal, but remember, in order to make it a percentage, you multiply it by 100, and that means you just scooch that decimal place over 2 spots. So the answer would be 12 hundredths or 12%, which is again equivalent. All right, and the last method that we're going to use to check it is this one, where you take the part, and that's equal to the percentage times the whole. Now, just something to point out, remember, we're using the percentage as a decimal. We're not using it as an actual percentage, right? Because 12 times 100 is going to be different than 12 hundredths times 1,000, right? So if this is all correct, it should give us an answer of 120. Let's do the math. And it works, my friends. Isn't that so amazing? When we did this math, when we multiplied 12 hundredths, which is the same as 12%, times our whole, which was 1,000, we got the part, which was 120. So, my friends, what we just proved was that you can use all of these equations to get the same answer, and you'll get the same answer because it's all proving the same point. Let's take a peek at number 5 on page 158. All right, so let's take a peek at this one. This problem, number 5, is all about mixing paint to make the beautiful shade of seafoam green, my friends. And in order to make this lovely shade of seafoam green, I need blue and I need yellow. But I don't need them like 50-50. I need a little bit more blue than I need yellow, right? So here's the information that we have. Here's what we got going on. There's a picture in the book next to this problem. That's where I got this information from, my friends. I didn't just like make it up out of nowhere. This comes from the picture, just so you know, okay? All right, so we know that the total amount of paint I'm making is 1.5 quarts. Now, don't worry about the measurements. We were not really gonna have to worry about converting those to gallons or any of that business, right? Just so you know, that's our whole. The total amount of paint that I am trying to get is 1.5 quarts. Now, in order to get 1.5 quarts, I need 70% of blue paint and 30% of yellow paint. Now, the question that I'm being asked, my friends, is how much yellow paint do I need? So while blue is a very nice color, it's a very nice information to know, you actually don't really need this piece of information in order to solve number 5. That's just like an extra piece of, like a little factoid, just a little nice to know, right? But we're dealing with yellow. So what we're gonna do first, my friends, we're gonna use this bad boy, right? Our percent proportion to plug in the information that we have so we can figure out the information that we don't have. So I've used the proportion down here to plug in the information that I have. The part, that's the unknown, that's what I'm trying to figure out. The whole is 1.5 quarts, that's quarts right down there. That's going to be equal to 30% out of 100. Remember, bottom of this equation, always 100 because percents are related to 100. Now, let's solve it. Our first step will be to cross multiply. That'll be 1.5 times 30, and then we'll have to divide, which will be dividing by 100. When we do the math, we find out that 1.5 times 30 is 45. Now let's divide that by 100. Remember, my friends, when you are dividing by a power of 10, you can just take that decimal, scoot it over twice. So that will bring your answer to 45 hundredths, or 0.45 quarts, right? So 30% of this seafoam green that I'm making is going to be yellow paint. How much exactly is that? Well, it's 45 hundredths of a quart. Now, let's use these other two expressions over here to test that out. Are we correct? All right, so the first method that we're going to use to check it is when we take the part, divide it by the whole, and that should give us a percentage. Now, remember, though, it's not going to give us the percentage as a whole number. It's going to give us the percentage as a decimal. So what would 30% look like as a decimal? As a decimal, we can say that it would be equal to 3/10 or 30 hundredths. Again, that's going to be equivalent to 30%. So now let's do the math. So once we've done this calculation, my friend, once I've taken 45 hundredths and divided it by 1.5, my answer is 3/10. But remember, That's equivalent to 30%, right? All right, let's try our next method. All right, so for this next part, let's use this last one, the percent times the whole equals the part, to check it out. So we have 30% times 1.5, that was our whole, and that should equal the part, which was 45 hundredths. Now, remember, my friends, we can't just use the percentage in the percentage format. We need to make that into a decimal. And like we just talked about, we could also use 3/10 or 30 hundredths as the decimal in order to continue. That's what this is what that would look like. All right, my friends, so when we take 30% or convert that into our decimal, which is also 3/10, and we multiply that by our whole, which was 1.5, our answer is 45 hundredths, which was the part that we already calculated. So what we did, my friends, is we used these 3 different methods to check ourselves, right? To make sure that we're on the right track. All right, you fine people, there's one more problem I'd like to look at together. It's still on page 158, and this is number 6. This problem talks about our friend Bill, who's able to buy a new laptop. Whoop, go Bill. Here's what we know. We know that he spent $35.99 in tax for that computer. The computer itself, without tax, cost $449.99. The question is, what percentage is this, right? What was the percent of the tax that he had to pay on his laptop? So let's use our proportion, our first one up here, and plug in the information that we have. So we can use this proportion like this. Our part was the tax, and we only know the tax amount, which was $35.99. We know the whole, that's the whole entire cost of his new laptop, which was $449.99. Our percentage, that's what's missing. So right now it's just a question mark because I don't know. Right? And then that's over 100 because our percent proportion is always over 100 because percents are always out of 100. Now let's start doing the math. Remember, we're going to cross multiply the 2 numbers that are diagonal buddies, and then we will divide that by the odd man out. It will look like this. So again, we're going to cross multiply our part times 100, so that's visible right here, and then we will divide it by our whole, which was $449.99, which will then give us our percentage. I solve what's in the parentheses. I get 3,599. I'm now going to divide that by the whole. When we do that calculation, my friend, we get a repeating decimal, 79979, and it keeps going on. So we're going to do some rounding. So we can say that this is really close to what percent? 8%, correct. So what we did was we found out that on this beautiful, nice laptop that our friend Bill just bought, he had to pay an 8% sales tax on it, which came out to be $35.99. Let's check to see if we are correct. So for this second method that we're going to use to check, remember, we're taking the part and we're dividing it by the whole. So $35.99 divided by $449.99. That should equal 8%. But remember, our calculator is going to give that to us as a decimal, which would be written as 800ths. Now let's do the math and let's see if we're correct. So again, my friends, just like with that last example, when we do this math, we get a repeating percentage, right, that we have to round up. Isn't it true that this number can also be written if we round to 800ths? Yeah, it's true. And so that means that it's also equivalent to about 8%. Let's check it one more time. The last way that we're going to check this, my friends, is remember the part is equal to the percentage times the whole. But remember, since we actually get a repeating decimal with this one, it might not be exact, right? We're doing some rounding to make this all possible. So first, how would we write 8% as a decimal? We would convert 8% into 800ths. Now let's multiply that by the whole. All right, my friends, so when we do that math, we actually end up with 35 and then some more numbers behind our decimal. But remember, we're talking about money, and for cents, we only go up into the thousands place, correct? So we'll have to round. So this is true, right? This is showing us that 8% of $449.99 is about $35.99. My friends, so that was just a quick run through of lesson 3-3, which again gives us more practice with percents and the proportions and the equations we can use in order to solve those problems. Again, please make sure that this is all in your notes because these are some handy tools that we will be using again. And of course, if you have any other questions, my friends, please ask.